Okay, I just need to share screen again, apparently. Let me share my screen. Okay. Right, we're going to look at determining the degree of a polynomial by a table given. What we're going to do for this one is we're going to look at how the y values are changing. So what we first need to examine is, do we have a constant increase happening here? We're going up by +2. You have to have a constant increase of +2 to be able to do this, otherwise it's not going to work. How much is it changing, the y value is changing here? It's going up by or down? Going down by how much? By -1. And then the next one? +2. And then the next one? +5. And the next one? I think 8. I think 8. Now, if that number I just calculated, looking at how the y values were changing, was the same all the time, it would be linear, wouldn't it? If this was a linear function, the rate at which it's changing would be constant, and it would be linear, and we would have a constant number there. We don't, so it's not linear. At this point, we have shown the function not to be linear. Now let's look at the rate at which the rate of change is changing. So we'll just repeat this again. How much do we change here?
3.
It goes up by 3. How about here? How about here? So what we call these, for this type of analysis, we call these the differences. So the first differences, these are the first differences. If the first differences are constant, it's linear. These are the second differences. These are the second differences. If the second differences are constant, it implies second differences are constant. This implies it is quadratic. Yeah. And so on and so on. So, determine the degree of the polynomial represented in table B. Try it for yourself.
What's the degree in the first one?
So the degree of f of x is 2. Let me do it like this. The mathematical notation for this is the degree of f is equal to 2. This is the shortest way you can write it.
But how do you know that it's equal to 2? Quadratic.
The second differences.
Then how do you know something is equal to like 3 or 4?
How many differences you have to take as constant? If it's the next one, we'll get cubic, so
Yep.
It was like the third difference is constant would be to degree 3.
Yes. Yes. So we look at the first differences. This is going up by 2. This is going up by 10. This goes up by 17. This goes up by 33? 23. Oh yeah, 23. This goes up by 8. This goes up by 7. This goes up by... This goes down by 1. By 1. So, we write the third differences are constant, which implies that the degree of G is equal to 3. Our last thing for today is odd and even functions. So an even function, it has a symmetry across the y-axis. So here we see an even function. It has a symmetry line here across the y-axis. And it is defined as f of minus x is equal to f of x. An odd function has a rotational symmetry around the origin, graphically, and it is defined using this definition here. G of minus x is equal to minus g of x. Let me show you how to use that with a proof. Show that the following polynomials are even, odd, or neither. So what we can do is we can start off with, if we start off with f of minus x and then see what the answer comes out. So we are going to start off with h of minus x. So we take 2, we put in our minus x here, we put in our minus x here, and we put in this. What is minus x to the power of 4? Minus x to the power of 4 is going to be x to the 4. And then minus x squared is simply going to be x squared. What is this? Notice that this is the same as the original function. So this is equal to h of x. Go back to your definitions. The yellow one, this is therefore an even function. So this implies h of x is even. Do you want to try the last one for yourself? Try the last one for yourself for a minute. 1 minute for that. Right, so we're looking at k to determine whether it is odd or even. So we start off with k of minus x is equal to minus x cubed plus 3 minus x minus 1, which is equal to minus x cubed minus 3x minus 1. Now, if we factor out the minus 1, we get x cubed plus 3x plus 1. And that is not quite this. So what I'm trying to do is to see whether it's going to be equal to, so this is not equal to minus k of x. It's also not equal to k of x. It doesn't quite come down to either of those two, which implies that it is neither odd nor even. Here is an exam-style question to finish us off for today. We have a test next Tuesday in this class. You have a minute and a half to solve a question like this. We should be able to finish before the end of class. Which is the right answer. Function is degree 3. Q of x equals 0. Therefore, it must be true. No. No. All right. Hands up for A. Hands up for B. Hands up for C. Hands up for D. The correct answer is C. Now, we don't know if it is going to be odd or even, so we can't sort of have this one. We only given one real root, so it could have two complex roots, but it could have two more real roots. We've just not been told them. This last one is true. It has definitely x equal to 5 as a root, so it has the linear factor x minus 5. Factoring that out from a cubic is going to leave you with a quadratic. So C is the correct answer.
Why can't it be D?
Nope.
Nope.
A rational function.
Then the degree of
All right, we are finished there for today.
Then the degree of 4 wouldn't make that.
Sorry, let me just finish this.